Hello friends, welcome to the session on continuous distribution. So far we have discussed about different types of discrete distribution. So today's class will be discussing about continuous distribution. What is continuous distribution? A distribution which works on continuous random variables, we call it as continuous distribution, right? So what are these continuous random variables? Those variables which change continuously, right? For example, water flowing from a dam, for example, the weight of an object. All these are continuous random variables, right? So the variables or the distribution which works for continuous random variables, we call it as continuous distribution, right? So it is defined like continuous random variables can be used to describe the random phenomena in which the variable of interest can take on any value in some interval of time. So continuous random variables are basically used for continuous distribution, right? So these variables can be used to describe any random phenomena. The random phenomena can be anything. For example, the traffic jam at a particular junction, right? So it can be a particular passenger coming and waiting for the bus. We'll be seeing different types of continuous distribution, right? So you'll understand what are the different random phenomena, right? So in which the variable of interest can take on any value in some interval of time, right? So the interval can be, say for example, 10 to 15 minutes or 20 to 30 minutes. That is what we mean by interval, right? So the example for continuous random variables is the weight of an object. There are so many types of continuous distribution. So here, in according to your syllabus, we have 9 continuous distribution which are listed as below. The first type of continuous distribution is uniform distribution. Second is exponential distribution. In uniform distribution, the variables are distributed uniformly. Uniformly in the sense, say for example, at the interval 1, then at the interval 2, interval 3, like that, right? So in exponential distribution, we have the variables which are distributed exponentially. There is an exponential growth in the distribution of the variables. Next, we have the third type of continuous distribution, which is gamma distribution. We have Erlang distribution, normal distribution, Weibull distribution, triangular distribution, log normal distribution, and beta distribution. These are the 9 types of continuous distribution which we'll be studying as a part of our syllabus, right? So out of these, the most important distributions are uniform distribution, exponential distribution, normal distribution, and triangular distribution. So most of the problems will be asked in your exam based on these 4 types of distribution: uniform, exponential, normal, and triangular. Let us start with the first type of distribution, which is uniform distribution. So what do you mean by uniform distribution? In uniform distribution, the random variable is uniformly distributed in the interval a comma b, right? So when I talk about the interval, it is a closed interval, right? So it starts from where a is the starting point and b is the ending point, right? So for any continuous distribution, right? So we have, for every distribution, there are 2 types of distribution functions. The first one is probability distribution function. The second is cumulative distribution function, right? So for uniform distribution, we have the probability distribution function given by small f of x. Small f of x is the small f is the variable which is used to denote the probability distribution function. So small f of x is equal to 1 divided by b minus a. B is the end of the interval and a is the start of the interval. So 1 divided by end minus start, right? So where my outcome of the experiment small x varies between a to b. So a is less than or equal to x, is less than or equal to b, and it is 0 otherwise. So this is the standard formula which you have to remember for uniform distribution, right? The cumulative distribution function is given by capital F of x. So capital F is the variable which is used to denote the cumulative distribution function. So capital F of x, it is equal to 0 if x is less than a, and it is x minus a divided by b minus a for a is less than or equal to x is less than b, and it is 1 for x is greater than or equal to b, right? So these are the 2 formulas for uniform distribution, right? So this is the small graph which shows us about how we can represent the uniform distribution, right? So as you can see here, we have interval 1 to 6, right? And the outcome or the value is uniformly distributed, right? These are some random values where what we have taken just to show that it is uniformly distributed. I can also write my uniform distribution in this way, right? So as you can see here, at value of x is equal to 1, right? So the graph is uniformly distributed, right, with the y count value increasing at a step of 0.2, 0.2, 0.4, 0.6, 0.8, 0.1, and so on, like that, right? So whenever we have two outcomes for our random variable, right, so then the formula is given by probability of x1 is less than capital X is less than x2, which is equal to f of x2 minus f of x1, right? So which is equal to x2 minus x1 divided by b minus a. You have to remember this formula. F of x2 minus f of x1 is equal to x2 minus x1 divided by b minus a. The mean for uniform distribution, right, it is also called as expectation of x, and the formula is E of x is equal to a plus b divided by 2. The variance v of x is given by v of x is equal to b minus a the whole square divided by 12, right? So these are the b minus a the whole square divided by 12. These are the different formulas which are used for our uniform distribution. So let us move on to the problems for uniform distribution. So we have a problem here, right? So the problem statement goes like this. A bus arrives every 20 minutes at a specified stop beginning at 6:40 a.m. and continuing till 8:40 a.m., right? So we have a bus which is coming exactly for 20 minutes time interval from 6:40 to 8:40 a.m., right? So 6:40 if I take as the starting time, the next time after 20 minutes will be 7 o'clock, right? So then next time will be 7:20, next it will be 7:40, then we'll have 8, 8:20 and 8:40. A certain passenger does not know the schedule, right, but arrives randomly, which is uniformly distributed between 7 and 7:30 a.m. So the passenger does not know the timing, and every morning he is coming between 7 a.m. and 7:30 a.m., right? So when he comes at exactly at 7, he will get the bus. If he comes at 7:20, he will get the bus. The next bus will be at 7:40, right? So what is the probability? The question says, what is the probability that the passenger waits for more than 5 minutes for a bus? He should wait for more than 5 minutes, right? So more than 5 minutes, for example, if he comes at 7, he will get a bus. Say for example, he comes at 7:1. When he comes at 7:1, he will be waiting for 19 minutes because the next time when the bus comes is at 7:20. If he comes at 7:2, he will be waiting for 18 minutes, right, because the next bus is at 7:20, right? The same way we will keep on calculating the different timings, right, for which he waits. But when he comes at 7:15 a.m., exactly if he comes at 7:15 a.m., he'll be waiting for exactly 5 minutes, right? So we should not consider the time between 7:15 to 7:20 because it is exactly 5 minutes, right? So what we do is look at the solution here. The passenger has to wait for more than 5 minutes. This is the condition what we have to find. The question is asked to find the probability that the passenger waits for more than 5 minutes, right? So the passenger has to wait for more than 5 minutes only if the arrival time is between 7 and 7:15. So I'm just taking an interval from A to B, 7 and 7:15, or between 7:20 and 7:30, right? So here also we will have the passenger waiting for more than 5 minutes because the next time when the bus comes is at 7:40 a.m., right? So I'm taking my capital X as a random variable that denotes the number of minutes past 7, right? Past 7 a.m. that the passenger arrives, right? So our starting interval here is A is equal to 0 and B is equal to 30 because the question is asked for to find the passenger is arriving from the timing 7 to 7:30, right? So that is why the interval is, our interval for uniform distribution is A is equal to 0 and B is equal to 30, right? So the probability that the passenger waits for more than 5 minutes is, we have to take these two intervals into account now, right? So I will be writing it as probability of x varies between 0 to 15 and probability of x varies between 20 to 30. So 0 is less than x is less than 15 and probability of 20 is less than x is less than 30. Right. So P of x1 is less than x is less than x2. The formula is f of x2 minus f of x1. As we have seen here, this is very, very important. You have to remember this formula. Probability of x1 is less than capital X is less than x2 is f of x2 minus f of x1, and it is x2 minus x1 divided by b minus a. Right. So what we do here is we will take f of 15 minus f of 0, right, plus f of 30 minus f of 20, right. Just substitute x2 minus x1 divided by b minus a and x2 minus x1 divided by b minus a and solve this. We'll get the answer as 5 divided by 6, right. So this is the problem on uniform distribution. Let's move on to the next type of distribution. It is exponential distribution, right. So a random variable x is said to be exponentially distributed. A random variable capital X, we call it to be exponentially distributed with the parameter lambda. The parameter used here is for exponential distribution, we are using a parameter which is called as lambda is greater than 0 if its PDF. PDF is probability distribution function which is given by f of x is equal to lambda e power minus lambda x for x greater than or equal to 0 and it is 0 otherwise, right. So if I take exponential distribution, it can be either decreasing exponential distribution or it can be increasingly exponentially distributed, right. So this is your exponential distribution graph, right. So you have to remember the formula for exponential distribution as f of x is equal to lambda e power minus lambda x for x greater than or equal to 0. The CDF, right, the cumulative distribution function, we obtain by integrating this particular equation, right. So let us call this equation as equation 1. So I have to integrate it in order to obtain my cumulative distribution function. So I will get capital F of x is 0 for x less than 0 and it is integration of 0 to small x lambda e power minus lambda t dt, right. So if I integrate it, I will get the answer as 1 minus e to the power of minus lambda t, right. So these are the standard formulas for exponential distribution. The mean of exponential distribution is given by e of x is equal to 1 by lambda and variance v of x is given by 1 by lambda square, right. So you have to remember all these formulas if they ask for exponential distribution. Exponential distribution is PDF is given by lambda e power minus lambda x and CDF is obtained by integrating the PDF. We get it as 1 minus e power minus lambda t. There are different applications of exponential distribution, right. So exponential distribution is used to model the inter-arrival times when the arrivals are completely random. We have already solved so many problems on inter-arrival times like single channel queuing system and two channel queuing system, right. So whenever we have to model the inter-arrival times when the arrivals are random, right, we make use of exponential distribution. We also make use of exponential distribution whenever we have to model the service times that are highly variable. When the service times are varying, right, so we have seen what do you mean by service time. Service time is nothing but the time taken, the time which the customer requires to be serviced by the server, right, how much time he needs to get service, that is called a service time, right. So if those service times are also varying, right, then we make use of exponential distribution. It is also used to model the lifetime of a component that fails catastrophically, right, that fails instantaneously, such as the light bulb, right, then lambda is a failure rate, right. So these are the three different types of application to model the lifetime of a component, right. So if I take a light bulb, it keeps on, it will be failed, right, that means it will not work after a period of time, right. So in order to model the lifetime of such components which keep on failing, right, so that particular for such applications also we make use of exponential distribution, right. Moving on to the problems. The first problem is, suppose the life of an industrial lamp in thousands of hours is exponentially distributed with failure rate lambda is equal to 1 by 3. One failure every 3000 hours on an average, right? This is what they have given. Suppose the life of an industrial lamp. There is a lamp, right? in thousands of hours. The life of a lamp is determined in terms of thousands of hours, and it is exponentially distributed with the failure rate of lambda is equal to 1 by 3. We have to find the probability that the lamp lasts longer than its mean life, right? So longer than its mean life means longer than its mean life, which is lambda. Find the probability that the lamp lasts between 2 to 3 hours, right? Two sub questions are given here. The first question is find the probability that the lamp lasts longer than its mean life. Second question is find the probability that the lamp lasts between 2 to 3 hours, right? So for the first question, the lamp lasts longer than its mean life, right? So what is the mean life? Mean life is lambda is equal to 1 divided by 3, right? So what we do is here, they have given longer than its mean life, right? So we have the formula for mean. The formula for mean is E of x is equal to 1 by lambda. So what I do is 1 by lambda, so 1 divided by 1 by 3. So 1 divided by 1 by 3, I will get it as 3, right? So I have to find the probability that it is longer than its mean life. So I take probability of x greater than 3, right? So probability of a x greater than b is 1 minus x greater than 3. I can write it as 1 minus probability of x less than or equal to 3. Probability of x greater than 3, I write it as 1 minus probability of x less than or equal to 3. How did I get this 3? Right? Since the question says that the probability that the lamp lasts longer than its mean life, what I do is I will take the formula which is used for mean of exponential distribution. The formula is 1 by lambda. So I will take 1 divided by lambda value is 1 by 3. So 1 by 1 by 3, I will get it as 3. Right? So I have to find probability of x greater than 3, which will be equal to 1 minus probability of x less than or equal to 3. Right? So then we have the formula capital F of x is what? 1 minus e power minus lambda x. Right? So I'll just substitute 1 minus e power minus lambda. Lambda is 1 by 3 and x is my 3 here. X is greater than or equal to 3. So x is equal to 3. Right? So if I solve this, I will get it as 1 minus 1. It will get cancelled. Minus into minus is plus. E to the power of minus 3 by 3. So 3 ones are 3. I will get e power minus 1. So calculate using your calculators, right? So you will get e to the power of minus 1 as 0.368. This is the probability that the lamp lasts longer than its mean life. The second question is find the probability that the lamp lasts between 2 to 3 hours, right? So if I have to find the probability that the lamp lasts between 2 to 3 hours, right? So I will write it as probability of 2 is less than or equal to x is less than or equal to 3, which is will be equal to f of x2 minus f of x1. That is the formula. So f of 3 minus f of 2. So find f of x. What is f of x formula? 1 minus e power minus lambda x. Just substitute that. Again f of 2, 1 minus e power minus lambda x, right? So lambda is 1 by 3, x is 2. So I will get 1 minus e to the power of minus 2 by 3. So if I solve this, I will get it as e to the power of minus 2 by 3 minus e to the power of minus 1. So calculate using calculator, you will get it the answer as 0.145. Next, we have one property of exponential distribution, which is called as memoryless property, right? So memoryless property means what? The future values of the exponentially distributed distribution are not affected by the past values. That is what we mean by memoryless. Memoryless means we are not keeping track of the past values, right? So the past values will not be able to affect our future values. That is why it is called as memoryless. You are not thinking about your past, right? So the memoryless property of the exponentially distributed random variable states that the future values of the exponentially distributed values are not affected by the past values, right? So in other words, it means that we know nothing about the future values of a random variable given a full history of the past, right? So we cannot take the past and we cannot decide about our future, right? So there is some small mathematical proof. This will not be asked in your exam. You just have to know that we have a memoryless property for exponential distribution, right? So mathematical proof, it says that probability for x is greater than s plus t. X is a random variable. It's greater than s plus t, or x is greater than s we get it as, right, so this is just a division, right, division of numerator probability divided by denominator probability. So I will get it as probability of x greater than s plus t. S is some time, right, so s is some variable, probability of x greater than s, some sample values, that is what we mean, sample values for future time and sample values for the current time, right. So probability of x greater than s is e to the power of minus lambda x, so minus lambda s plus t we write, and here it is e to the power of minus lambda s. So if I take this, this is your division of fractions, right, so a to the power of m divided by a to the power of n will be equal to a to the power of m minus n. So I'll be using that formula, so I will get it as e to the power of minus lambda s minus lambda t. Again this will go up, I will get it as plus lambda s here. So plus lambda s and minus lambda s will get cancelled, so I'll be left out with e to the power of minus lambda t, right. So this is equal to e to the power of minus lambda t, right, so which is nothing but probability of x greater than t, right. So this is the memoryless property. So for the previous problem, that is for the above problem, right, so we are continuing this problem. They have asked us to find the probability that the lamp lasts for another hour, right, so given it is operating for 2.5 hours, right, so it is operating for more than 1 hour, right. So what we do is we consider the probability of x for the current hour, given it is operating for 2.5 hours and it is operating for one more hour from 2.5. So one more hour from 2.5 will be 2.5 plus 1, which is nothing but 3.5 hours, right. So I will get it as probability of x greater than 3.5 divided by probability of x greater than 2.5, right. So which will be equal to probability of x is actually greater than 1 hour, right. Look at here, if I take x is greater than s plus t, right, divided by x is greater than s, what I am getting, I am getting the time what I am adding, extra 1 hour time, right. So probability of x greater than t I am getting, right. So that is why here that extra time what I am adding is another hour, so I will take it as probability of x greater than 1. So probability of x greater than 1 is actually what? 1 minus probability of x less than or equal to 1, right. So make use of the formula for exponential distribution, which is 1 minus e to the power of minus lambda x. So I'll get it as 1 minus of 1 minus e power minus lambda x. Solve this, you will get your answer, right. Hope it is clear, right. So the next problem what we have for exponential distribution is the lifetime of a satellite placed in an orbit is given by probability distribution function small f of x is equal to 0.4 e to the power of minus 0.4 x, x is greater than or equal to 0, right. So if the moment you see this, you can come to know that it is exponentially distribution because it is of the form lambda e power minus lambda x. The question says, what is the probability that the satellite is still alive after 5 years? That means we have to find probability of x greater than 5. And what is the probability that the satellite dies between 3 and 6 years? That means we have to find the probability that it is between 3 to 6 years from the time it is placed in an orbit, right? So solution goes like this. The lifetime of a satellite is exponentially distributed as, right, they have given f of x is equal to 0.4 e to the power of minus 0.4 x, which is same as lambda e power minus lambda x. This is the probability distribution function for exponential distribution. So from this value we can find that lambda value is equal to 0.4, right. So they have asked us to find what is the probability that the satellite is still alive after 5 years. After 5 years means we have to find the probability of x greater than 5. Probability of x greater than 5 is equal to 1 minus probability of x less than or equal to 5. So that will be equal to 1 minus f of 5, which is my cumulative distribution value, right. So I have the formula for exponential distribution as f of x is equal to 1 minus e power minus lambda x, right. So that will be equal to 1 minus e power minus lambda is 0.4 and x value is 5, right. So just substitute and solve this, you will get your answer. The second question was find what is the probability that the satellite dies between 3 and 6 years from the time it is placed in an orbit. So we have to find the probability between 3 and 6 years, right. So we take it as probability of 3 is less than or equal to x is less than or equal to 6. So which will be equal to f of 6 minus f of 3, right. So make use of the formula for exponential distribution, which is 1 minus e to the power of minus lambda x. We will get it as 1 minus e to the power of minus 0.4 into 6 minus of 1 minus e to the power of minus 0.4 into 3, right? So if you solve this, you will get your final answer, right? Thank you. Let us continue tomorrow with the next type of distribution, which is gamma distribution.